Welcome back to our video playlist on dynamic programming. In this video we're going to continue talking about rod cutting, and we're going to go ahead and follow the steps to actually write an algorithm to do the rod cutting. So in the last video we talked about the rod cutting algorithm. We have a rod, we have a table of how much we can sell each length rod for, and we want to know what our maximum basically revenue is on this. And our steps were we define what the optimal solution looks like. In this case, we're going to have a function. It's just going to return an integer to us, and that integer will be the total cost. Actually, I guess it could be a double. Prices could easily be doubles here. Then we're going to write this as a recursive function. Now that recursive function could be written in purely mathematical terms. I'm actually going to write it in C++ here because the class that where the students need this video happens to be taught in C++. And then after that we're going to convert that recursive version to a dynamic programming version. So let's do, I like to use VI here, VI for, and put in some of the basics. That will be sufficient at this point in time, at least. And let's see, I need a main. Yeah, we'll just go ahead and do that. Return 0. Let's make a vector of double prices equals 1, 3, 3, 5, 5, 7, 8, 3, 10, 10. And now what we really came here to do, which is we want to write the recursive version of the function that will solve this. So double I'll call it recur rod cutting, and we're going to pass in the prices. They don't need to change, so we'll be good programmers and make them const. I'm just going to call it P up in here. And so how do we define this function recursively? Well, we then this is the thing that doesn't change, but we do need an argument that does change, and that is the length that we are of the rod that we're considering here. Clearly, if n is less than 1, we return 0.0. Okay. If that's not the case, what do I need to do? Well, then I need to consider all the possibilities of combining, cutting 2 off with the recursive application to everything else, cutting 3 off with the recursive application to everything else. So I'm going to go ahead and make a variable called max here, and max will start off as the price of just if I don't cut off anything. And then we're going to write a for loop, I equals 1, I less than n plus plus I. Double temporary variable equals, well, this would be the price of cutting a chunk that is of size I plus a recursive call to the recursive rod cutting using the same price, and then n minus I. Okay. If temp is greater than max, max equals temp, return max. And we can test this out down here, see if we're doing things correctly. See out recur rod cutting of prices and 10. Okay, pull up another window here that I could compile this in. I'm just going to swap the positions of these. We'll run G++. I actually am using the newer standard with this line here, and see how many typos I had. Wow, none. 30. That so does not sound right. Okay, so there's no way for me to make 30 out of that. What did I mess up in this recursive function? Okay, if we're less than 1, return that. See out. I'm just interested in seeing what the recursion looks like here. And of course, this recurs a whole heck of a lot of times. Pipe to less. Okay. 10 called 9, called 8, called 7, called 6, called 5, called 4, called 3, called 2, called 1, called 1, called 2, 1, 1, 3, 2, 1, 1, 2, 1, 1. Actually looks like roughly the correct approach to this. So am I double counting something? I can only increment this. See out in I and temp. See out in max. That will also produce a whole heck of a lot of output. Oops, except I wanted to pipe to less. So, oh, but I have it, it's after the recursive call, so this is when you're popping back up the stack. So this says that 2 and 1, 2, oh, and I, oops, definitely need to put a new line there, otherwise I'm going to have no idea what the heck is going on. Okay. So when it got down to 1, it returned max is equal to 3. Oh, I see why. This is a very simple problem here. My price array is, or it's a vector, and or even if it were array, it's 0 indexed. So I need to put in a value for 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And that actually could have caused our entire problem. Now we're getting 15. The only way I can see to get 15 out of this would be like, I know length 4 and a length 6 doesn't give me, I don't think I can get 15. So we'll see what this is doing. Okay, so with length 1 we got 1, with n equal 2 and I equal 1 we get 2, because that is 2 chunks of length 1, but then it winds up giving a max of 3. That is correct. A 3 and a 1 wound up giving us back 4, which is correct if you look on our table here. A 3 and a 1 would be 4. A 3 and a 2 is also 4, because that means that we're one way is a 2 and a 1, the other is a 1 and a 2. So they're both going to be the same, and the max is 4 there. 4 and a 1, it says, is 5, and that is for the temp. So this would be a chunk of length So a chunk of length 1, which is size 1, plus the maximum of a recursive call on 4, and the recursive call on 4 should wind up producing something of value 4, and we're good. So at least at small inputs, I like my recurrence relationship. I don't think that anything appears to be wrong here. Something of length 5, and it managed to find a value of 7, because the 5 came out to the 2 and the 3, and then the 1 chunk gave a 7. Okay. 5 and 2, 7 is also correct. 7 and 1. So it needs to find a way to make 9 out of a 6. Which we can do. We can do a 6 and 2 1s to get the 9, and then another one gives us a 10, and that's how we get 15. Okay, so this will actually work. So if we do so let's see. So if I have something of, so our original rod, if our original rod is length 10, I still can't go more than the best thing that I can do with a 6, well, I can get up to 9 that way, 3 2s. Okay, so I can get 3 2s there in the 6 and the 4, so I can definitely get a 14. I have a funny feeling there is a way to get a 15, and I'm not seeing it. So anyway, this was our recursive function. I spent enough time playing with it here. I'll spend a little bit more to make sure that it's actually correct, and then we'll come back in the next video and we'll look at how to convert this recursive function to something that does it bottom up. Because as you can already tell from just the run here, this is doing a whole lot of recursive calls. Okay, this is doing a lot of work, and it's because right now it is it's solving the same sub-problem over and over and over again, and we want to fix that by employing dynamic programming.